So we left off here where we saw the first two kinematic equations. Now we'll look at the other two or three. And so again, I'm going to use the same graph, and I am going to say, okay, this time I'm going to find the area of this this trapezoid, but I'm going to do it in breaking it into parts. So let's take this first part. This first part is just the height is VI, the width is T. That's just a rectangle. A rectangle is just length times width. And so the area is just going to be VI times T. That's just one part of this whole thing. Remember, what the area is going to give us again is displacement. So displacement is going to be VI times T plus the junk I need to get from here. Well, let's look at what we have here. This triangle has a length, a width of, or a base of T and the height of VF minus VI. So the area of this triangle would be half base times height. That's the area for a triangle. So it'd be half times H, which is VF minus VI. But then I say, okay, I want to take you back to this equation here and say, well, isn't VF minus VI the same as A times T? Sure it is. If I multiply both sides by T, that's what I got here, right? VF minus VI is the same as AT. So instead of putting VF and VI, I want to put AT in there. The reason is I want to make this equation something special that doesn't need final velocity in there, and I'm going to try to get rid of it. So that's why I don't want final velocity in this equation. So then I have, this becomes 1/2 times T times A times T. Well, if I multiply that, that becomes 1/2 times A times T, which is 1/2 AT squared. So I bring that back up and I add it up here. So my displacement totally is VIT plus 1/2 AT squared. And that is our third kinematic equation. For the fourth one, I think I got enough room here. All we got to do is kind of manipulate some numbers around, okay? And just kind of do a little bit of fun algebra. And it really isn't hard at all. Okay, so let's look at it this way. We already have one equation that says delta x equals VF plus VI over 2 times T, right? That's our first equation. Take you back up here to it. So we already have this guy. Now, what I want in this special equation, if you look at all the equations I got so far, they all have time in them. See, time here, time there, time there. What if I want an equation that I don't, when time is not given and I need to solve stuff, right? So that's why I'm going to get rid of this T. And remember in algebra back when you had two equations and two unknowns, you could substitute one in the other. So here's where I'm going to get my T from. Right here, if VF minus VI equals A times T, if I divide both sides by A, I get T is equal to VF minus VI over A. I'm going to put that here instead of this T. So in the next line, instead of putting T, I'm going to simply put VF minus VI over A. And then I'm going to multiply it to simplify this, multiply both sides by 2 times A. That would make that and that cancel. I hope you can see that. And so I have 2 times A times delta x is equal to VF plus VI times VF minus VI. When you multiply all this out, I hope you can see this is the same as A plus B. A minus B becomes A squared minus B squared, but I'll still do the whole thing for you. So here we go. 2A delta x is equal to VF squared plus VF VI minus VF VI minus VI squared. Those two terms cancel. leaving you with 2a delta x is equal to vf squared minus vi squared. We're almost there. So I'm going to add vi squared to both sides. And I end up with vf squared is equal to vi squared plus 2 times a times delta x, which is our displacement. And right there, that is your fourth equation. Oops, there we go. There's your fourth equation. A lot of people say, hey, we want a fifth equation as well, because if you look in all of these, there's 5 variables. That's what we started off with up here. 5 different things you would want to know. And there's 4 equations. Each one has something that's not there. Well, which one's missing? Well, there's initial velocity. And if you really wanted to do that one and come up with a fifth equation, you can do that as well. Okay? Let me show that to you in the next video.